thank everyone for coming here today to talk about one of the most popular technologies today, and that's certainly artificial intelligence. I'm Nikola, and today I will be talking about machine learning and how machines are used to process natural languages. I'll start with a little bit of history. People talked about intelligence and intelligent machines in the 19th century. They started with the first computer, which you can see here. It was called analytical engine, and it was used to make some arithmetic operations, for example, to sum two numbers or to subtract two numbers. People started thinking if these machines could be intelligent. At that time, it was not possible. After that, in 20th century, people started making some improved algorithms and methods, so they started thinking about some new methods, and one of this is the Turing test. Alan Turing in 1950s invented the Turing test, so he introduced it to test if the machines can be intelligent. Of course, at that time also, the machines couldn't be any kind of intelligence. After that, engineers and linguists started experimenting with handcrafted rules. They made rules for some programs, they invented some programming languages, and they thought that if they can write programs or programming languages, they can write a rule set of English. So it was a fixed set of complex rules. Until the 1990s, they continued with these methods, and they realized that they cannot write all the rules for some kind of algorithms, especially for intelligent algorithms. So after that, around 1990s, they invented new methods, and these methods were called machine learning methods and statistical approaches. So what do statistical models do? They take, for example, this sentence, I called her, but she did not, and they try to predict the next word. In natural languages, they try to predict one next word. So if we see these possible words, we would say that the most probable word would be answer. She did not answer. But statistical models didn't think like that. They just see these two words that I rounded here in red circle. So they try to predict the next word just seeing these two words. And they try to predict it with the most probable word that appeared in the previous text. So it will probably be the word have. After that, they saw that there were a lot of mistakes with these systems, and they tried improving them, and they improved them with the new family of models, and they were called sequence models. These models were popular and are popular still today because they put attention on a more broader sense of the words. They don't just look at two words like statistical models, they look at the whole sentence, for example. So they can make better predictions, and in this case, the sequence model would predict that the next word would be she did not answer. If you see here in these rectangles, for example, these models are functioning like this. They take the word I, for example, in this orange rectangle, and the word I is present in all these rectangles on the right side. So it becomes smaller. When you want to predict the word answer, the word I would have very small importance in this prediction, but it will be present there. These statistical models or these approaches were used for example, for Google Translate or Google predictions or suggestions 10 years ago. Scientists realized that they were not enough. They were not having good precision because they didn't put too much attention on a broader context of words and sentences. So in 2017 and 2018, a new architecture rose to the popularity, and it was called the transformer. And the ChatGPT that we have today is a transformer model. Why is it important? It is important because it models the dependencies between the distant words in the sentences. It should not be in one sentence, it can be in different sentences, in different paragraphs, and different pages of the book maybe. So they are trained to predict the next word, having in mind all these words behind or previous to them. So why it happens now? It happens, researchers in the 1990s started with experimenting with neural networks that were the first AI models that we know, and they started experimenting with data. They increased the amount of data, and then they realized that the performance improves. But it is not infinite improvement. It just improves until some point. After that point, if you increase the data, you don't get the increased performance. So they invented new ways of improving these models, and they started improving the architecture of the models. So the models became bigger and bigger. And today we are witnessing the large language models, which are the biggest models that we have today. So today we have big data, we have a lot of massive amounts of data, and we have the biggest models ever. So where do we put large language models, or LLMs? LLMs are AI, or artificial intelligence systems, because they exhibit some kind of human intelligence in generating text. They are also machine learning models because they are learning from data automatically. They can also be defined as deep learning models because they have deep layers that are training from data and trying to learn something. And in the last few years, a new field rose to the popularity, and it is called generative AI. As the name says, it is used for generating multimedia content, and LLMs are the subset of generative AI methods. So I was talking a lot about transformers and LLMs, and that LLMs are essentially transformer models. And now I will dig deeper inside of this transformer model. So I'll take one example, and this is the translation of the text. And for example, the input text is in English, this is an example, and the output text is in Italian. These models were invented in 2017, and there is a very popular research paper that is called "Attention is All You Need," which you can read, and it is based on translation of the text. Researchers were trying to improve the Google Translate from 10 years ago, and they improved it with these systems. So these transformer models are comprised of two parts. It's encoder and decoder. Encoder part sees all the input text, which is in English, and makes some codes of it. It encodes it. I depicted it here in some colors. What is the encoder part is trying to make sense of the input sentence. It is trying to make all the relevant words and the context of these words so it can feed it to the next part of the transformer model, and it is called decoder. Decoder takes these encodings and it tries to decode the translated text one word by one. That's all. Researchers in the past few years also realized that they can separate these two components, the encoder and decoder part, and they can make separate architectures and separate transformer models from them. So on the left side, you can see encoder transformer, which is usually called BERT today, and it is used, for example, to classify the text. It is used, for example, to classify the documentation, or maybe it is used today on Twitter to detect toxic words and toxic text on the Twitter. So how does it function? It is trained separately than the decoder part. It is trained, the input sentence is depicted here, and you can see that there are hidden words in this input sentence. What is trying to do? The encoder is trying during the training process to predict what are these hidden words. So that's the training process. We feed it with a large amount of data, we hide some of the words, and it is trying to predict them. After that, the decoder can be used to detect toxic content on the Twitter. On the right side, you can see the decoder model, which is usually called GPT, and it is used to predict the next word. So it is predicting, we hide the final word here, answer, and it tries to predict it in some contextual manner. So when I say GPT and when we see ChatGPT today, we are certainly talking about GPT transformers, which is the abbreviation for generative pre-trained transformer. It is generative because it generates text. It is pre-trained on massive amounts of data, and it is a transformer model consisting only of the decoder part of the original transformer. So the only aim of this GPT model is to predict the next word in the sentence, only one word. So the original transformer had only 6 these encoders and decoders in its architecture. In 2020, the GPT-3 appeared, and it was just a scaled-up version of the original transformer. It had 96 decoder layers and 175 billion parameters in it. So what we are seeing today is always the scaled-up process of the original transformer. If you see the Llama 3, which appeared 2 days ago, it is just a scale-up version of the original transformer. It has a lot of these decoder layers, and if you know the basic structure of the original decoder, then you know the basic structure of all these large language models today. So how they are developed? LLMs are developed in these three stages today. First, we are starting with a lot of data. We are pre-processing the data. We are feeding that data to the model. And then we are making some kind of general model, which is, for example, a ChatGPT. After that, these models are used by scientists and researchers and engineers, so they can fine-tune these models on some specific tasks. ChatGPT can be used, for example, to ask questions about sports, medicine, finance, etc. But specific models can be used just to ask questions about some specific topic. For example, you can use Bloomberg GPT, which appeared 2 years ago, and you can ask him a lot of finance questions, and it will be much more precise than the ChatGPT model. So these are the three stages, and they are used to make models for classification, for personal assistance, for instructions, classification, and others. So finally, I'll just summarize my presentation with some of the points. So LLMs transformed the field of NLP. They use deep learning methods, which were known for a lot of time, but can be used just today because of the compute power that we have and because of the massive data sets that we have today. Modern LLMs are first pre-trained on a lot of data and on general tasks, and after that they are fine-tuned on some specific tasks and they have very good precision at it. LLMs are based on the transformer architecture, and the main mechanism in this transformer is the attention mechanism, which puts attention on the broad context of words in the paragraphs and pages of the book, for example. And the original transformer consisted of encoder and decoder, and when we are talking about GPT today, we are just talking about the decoder part of this architecture. This point is one of the most important for me. So the general pre-training task of the GPT is to predict the next word. But during training these models, researchers realized that they can exhibit emergent characteristics or properties, and these emergent properties are classification, for example, translation, or summarization of the texts. It's not just predicting just the word, but they can do a lot of other tasks. So finally, LLMs which are fine-tuned on custom data sets, which is a very popular trend today in the companies, they can and certainly outperform general LLMs on specific tasks. That's it. Any questions?
Any questions for Nikola? Thank you, Nikola.
You mentioned Llama 3. Considering it's open source, what type of data does Meta have to outperform other companies, considering the code itself is open source and everyone has access to the layers Meta used to create that large language model? So that's the question.
Well, big advantage of Llama 3 is that it's definitely open source. Yeah, we have a lot of open source models that are emerging today. The advantage of Llama 3 is that it was trained on one of the largest data sets, open data sets. As I know, it's trained on open web internet data. It's trained on 15 trillion tokens. It's something about 20 terabytes of data, textual data, which is one of the biggest data sets that the researchers know about, open data sets. And it's also trained on 24,000 GPUs. I think 2 clusters on 24,000 GPUs. So it's massive data, it's massive amount of layers in this architecture, and massive amount of hardware that was used to train this model. So if I recall, the Llama 3 is in 2 variants. It's 8 billion parameters, one model, and the second one is 17 billion parameters. And they are training a new one, which is 250 billion parameters, I think. So this one would probably be one of the most important open source models that researchers can use to fine-tune it on their specific tasks. So they have advantage in hardware, in data sets, and they're using it to scale up these transformer models so that it can be some kind intelligent.
feel free to challenge Nikola on any of the numbers that he just gave away. So maybe 249 billion parameters.
Yeah.
Does this answer the question?
Yeah.
Yeah, sure, go on.
I assume those GPUs are the ones that they ordered from NVIDIA previously.
Probably they say that it's custom built GPU cluster, but they didn't mention what kind of GPUs, but it definitely must be NVIDIA.
The one that you're referring is actually 300, maybe 350,000 GPUs.
Yeah.
The one with the billion, so it's much larger than the one mentioned, and it's yet to be delivered.
I think there was another review. Who's asked the question? Okay, cool. So, Nikola, thank you very much.
Thank you.
You'll have a chance to talk with Nikola afterwards. Also, we'll have 3 more short lectures. Then we'll have a short break, and then we'll also have a panel. Okay. The next.